This is our fourth lesson in polynomials, and our main topic here today is being able to perform operations on polynomials. We've talked about graphing. If I've got something in the parentheses form, being able to actually go and graph some of those things. Well, now we want to look at when I'm actually talking about polynomials, how can I combine some together? What happens if I subtract them? What happens if I try to FOIL and multiply more than just two sets of parentheses? Eventually we want to get to where it's one big polynomial, x cubed, x squared, x and a number, maybe x to the fourth in front, maybe x to the fifth in front. But in order to get to that, a lot of times we need to know what does it look like in factored form. So we're going to talk about operations like addition, subtraction, multiplication. Division will come later, but today we're going to be talking about those main three operations, and we're going to look at a couple examples and maybe a couple different methods on how to multiply. First problem we have up here is a subtraction problem, 7x cubed minus 1 minus all of that, the second polynomial. And if this were a plus sign in between, if it was just one polynomial plus another, it's just a combining like terms type problem. Take my x cubes and add them together, take my x squareds and add them together if I can. Since it's one minus the other, really the only thing that's important for us to know here is that this negative applies to everything in the next parentheses. Really what I'm going to do is I'm going to distribute this negative to all four items, to the x cubed, the x squared, the x, and the number, and that's going to change my polynomial to something else, and I have to do that before I add it to the other. That's going to make my second polynomial a negative 15x squared, a negative 4x squared, sorry, the first one is cubed, a positive x, and a negative 3. And I want to take this and combine it with my 7x cubed minus 1 at the beginning. Once I've gotten rid of that negative sign, I really don't need the parentheses anymore, and at this point I'm just adding and trying to add and subtract like terms. Like terms are this. I've got x cubed and x cubed. 7 minus 15 is negative 8. So it's negative 8x cubed. I only have one x squared, so it's negative 4x squared. I only have one x, so it's a positive x. And then with my numbers, I have negative 1 and negative 3. That gives me negative 4. The things that we need to make sure we are good at for these problems is 1, distributing a negative, and then 2, just adding like terms, making sure that you're good with positives and negatives. Positive 7, negative 15 gets us to negative 8. Make sure you know those rules of adding and subtracting integers, whether positives or negatives, because that's going to be where most of our errors show up in these problems here. When we're multiplying, we want to be able to look at this and do one step at a time. A lot of times when we see these, I see students trying to do all of it together, and that's where you're going to run into some issues. My suggestion is this. If you see 3 items, multiply the first 2. We can use the FOIL method, the box method, whatever you have to do. But do something to multiply your first 2 parentheses and find an answer. In this, that's going to be 2x squared minus 5x minus 3. If you need to pause and go to your paper and actually multiply them together, you can do that now. Once you get to your answer, what you'll do is you'll multiply that times the last one. This times x minus 2 is going to give us our answer from here. And this is where we have a couple of different methods. If I'm multiplying, since there's 3 items in here, this is called a trinomial, and there's 2 items in here, which is a binomial, that's different than just a 2 times 2. This is where FOIL method's not going to work anymore. And so what I would suggest is one of 2 methods, either the distributive method, and I'll show us that here first, or the box method. Box method still works. I like that method for this. I think it works really well. And I'll show us an example of that next. If I do this problem with the distributive method, what I'm doing is I'm taking, let's say we're looking at my smaller one here in this case, and I'm taking the first of my smaller one and distributing it to the other set of parentheses, x times each of those 3. We're going to get 3 different answers. So x times the first is 2x cubed. X times the second is negative 5x squared, and x times negative 3 is negative 3x. I take the first and distribute it and get an answer. I then take the second and distribute it and get a second answer. Negative 2 times 2x squared is negative 4x squared. Negative 2 and negative 5x is positive 10x. Negative 2 and negative 3 is positive 6. And if you notice that when I wrote these down as my two answers, the x times everything and the negative 2 times everything, I wrote it up vertically because I'm going to add the two together, and I lined up like terms. So the x squared and x squared are in a column, the x and x are in a column, and that's going to be helpful when we've got a lot of things going on. It helps keep us organized so that we have, this is our first answer, this is the second, and then add vertically to add like terms. But you need to make sure that when you're multiplying x times something, that you know what to do with that answer. We'll review a little bit of rules of exponents here and there, but make sure you know how to multiply, like say an x and an x squared to get an x cubed. From there, we do is we just add like terms again. And so we add the first column, we get 2x cubed. Those are all the like terms that are there. Second column, we've got negative 5 and negative 4, which is negative 9x squared. Third, I've got negative 3x, positive 10x, which is a 7x. And then our last one is plus 6. And this is what my final answer will look like. 2x cubed minus 9x squared plus 7x plus 6. It's a larger answer, and they're going to get bigger when I get more parentheses. But this is what my answer looks like when I FOIL together several sets of parentheses here. The last example I want to look at is I want to show you what the box method looks like when we're multiplying these polynomials together, because it is a little bit different, and it's important that we see how the box method is extending it beyond just 2 by 2 is not that much more difficult. With the box method, what I would suggest is to take one of your polynomials, preferably the larger one, and put it on top. And so we're going to have 3x squared, negative 2x, and positive 4 along the top of my box. Since there's 3 items, I want my box to be 3 columns. Along the left-hand side is going to be our second one. And since there's 2 items there, we've got 2 rows to accommodate that. There's an x and there's a negative 3. Now what's nice about the box method is that with quadratics, all we did was multiply the top one and the left one, and the answer goes in the box. And it's the exact same thing here. Nothing changes. It's just that my box is bigger. And that's why I like this method for organization. I know that I'm going to have 6 little answers, and once I find those 6, I'm done. I have all the answers that I need, and I just combine like terms. So it's really good if you're having trouble with the organization of the distributive method and multiplying polynomials. To get my answer, I just multiply top by left. So I'm going to have 3x cubed, negative 2x squared, and a positive 4x. And the top row is going to be the top half of my answer. In the distributive method, that's just taking the x and distributing it by our polynomial. So we did that one already. It's just written differently. The second row is negative 3 times each. So this box is negative 3 times 3x squared, or negative 9x squared. Second box is going to be a positive 6x, and the third is a negative 12. If you need to stop your video so that you can do this yourself and know that you can get these answers, you can do that at this point. And then when we find our answer, what we'll do is just combine like terms. We have 3x cubed. These 2 are like terms. That's a negative 11x squared. These 2 are like terms, and that's a positive 10x, and then my negative 12. And these diagonals are very often going to be like terms. And so that's a thing I like about this, is that like terms are usually going to be right next to each other. Our final answer, like the last one, is the big polynomial. It does look kind of weird. It looks kind of menacing. And we'll talk more about this stuff later. Today, this is our final answer, and then